Hi, welcome back to SQL Database Administration Hub. Today, we're talking about DBCC CHECKDB and database integrity checks. Database corruption is one of the most serious problems a DBA can face, and CHECKDB is your primary tool for detecting it early. Let's break it down. Database corruption happens when data pages on disk become damaged or inconsistent due to hardware failures, storage issues, driver bugs, or unexpected shutdowns. Left undetected, corruption can spread and ultimately result in data loss. DBCC CHECKDB is SQL Server's built-in integrity checking command that scans your database for corruption and reports any problems it finds. In this video, we'll cover how corruption is detected, the different ways to run CHECKDB, and best practices for making integrity checks a regular part of your maintenance routine. Before we run CHECKDB, it's worth understanding what kinds of corruption SQL Server can detect and where corruption typically originates. SQL Server detects two main types of corruption. Physical corruption is damage to the actual data pages, torn pages, checksum failures, or missing pages. SQL Server detects this using page checksums, which are written when a page is saved to disk, and verified every time that page is read back. If the checksum doesn't match, SQL Server knows the page has been damaged. Logical corruption is subtler. The page is physically intact, but the data within it is internally inconsistent.
For example, an index that doesn't match the data in its underlying table, or broken forward and backward pointers between pages.
Logical corruption is harder to catch and is exactly what CHECKDB is designed to find. Common causes of corruption include failing hard drives, faulty storage controllers, SAN misconfiguration, memory errors, and sudden power loss without proper shutdown. This is why running SQL Server on reliable hardware with proper UPS protection matters. But even with the best hardware, corruption can still occur, which is why regular integrity checks are non-negotiable. The basic command to run a full integrity check on a database is DBCC CHECKDB SalesDB with no info-mess. The no info-mess option suppresses informational messages and only shows warnings and errors, making the output easier to read. Running this command checks the allocation structures, all tables and indexes, service broker objects, and catalog views. For very large databases where a full CHECKDB takes too long to complete in a maintenance window, you can break it into smaller pieces. Use checkalloc to check just the allocation structures, checktable to check individual tables one at a time, and checkcatalog to check system catalog consistency. Running these on a rotation throughout the week gives you coverage without the full runtime hit. DBCC CHECKDB also supports the physical-only option. DBCC CHECKDB ERS with physical only. This limits the check to physical page integrity and allocation structures only, skipping the more time-consuming logical checks. It runs much faster and is useful for a quick daily check, with a full CHECKDB run weekly or monthly depending on database size. When CHECKDB finds corruption, it reports it with error 823, 824, or 825. These are serious errors that require immediate attention. Here are the best practices every DBA should follow for integrity checks. Run CHECKDB regularly. For most databases, weekly is the minimum. For critical databases, consider running it more frequently. The longer corruption goes undetected, the more it can spread, and the more backup history you may need to go back through to find a clean restore point. Run CHECKDB against a backup, not production, where possible. For very large databases, restoring a backup to a secondary server and running CHECKDB there avoids the I/O and CPU load on production. Automate CHECKDB with SQL Server Agent. Create a job that runs CHECKDB on a schedule and alerts you if it returns any errors. The Ola Hallengren maintenance solution, a free, widely used script available online, includes a well-designed integrity check job that many DBAs use in production. Don't ignore errors. If CheckDB reports corruption, treat it as an emergency. Investigate immediately, assess the scope of damage, and begin recovery procedures. Corruption doesn't fix itself and will only get worse. Keep verified backups. The most important recovery tool for corruption is a clean backup taken before the corruption occurred. This is yet another reason why regular, tested backups are essential. And that's DBCC CHECKDB and integrity checks covered. To recap, SQL Server detects physical corruption through page checksums and logical corruption through internal consistency checks. And CheckDB is the command that runs all of these checks for you. You can run a full CheckDB, use Flysicle only for faster checks. Or break it into checkalloc, checktable, and checkcatalog for large databases. And your best practices, run checks regularly, automate them with SQL Server Agent. Investigate every error immediately, and keep clean, verified backups. Are the habits that keep corruption from becoming a catastrophe. Subscribe so you don't miss the next video, and I'll see you there.
Generous Academy.